the world once slept beneath ice. For 10 million years, the oceans froze, mountains sighed beneath glaciers, and the sky dimmed to silver stillness. No sound but the crack of frost. No color but pale blue. Yet beneath miles of frozen ocean life whispered, tiny, invisible, unbroken. This is the story of that silence, of how our planet nearly died, and how, in the coldest night in Earth's history, life learned to dream again. In the beginning, there was warmth. 650 million years ago, when time itself moved differently, and the sun hung younger in an alien sky, Earth breathed in colors that no human eye would ever witness. The planet turned slowly, a blue-green jewel suspended in the cosmic dark, its surface painted in hues of jade and amber, beneath clouds that drifted like lazy thoughts across endless skies. The oceans stretched unbroken from horizon to horizon, shallow and warm, their surfaces disturbed only by the gentle pull of ancient tides and the whisper of winds that carried no names, no stories, no memory of what was to come. These waters held a secret, a living carpet that spread across the seafloor like nature's first attempt at consciousness. Microbial mats, billions upon billions of tiny architects, weaving themselves into existence with patient, methodical purpose. They built their cities in layers, microscopic skyscrapers of minerals, and organic matter that rose from the ocean floor in domes and towers, no larger than a child's hand. These were Earth's first cathedrals, places of worship to the chemistry of life itself, where sunlight was transformed into energy with an efficiency that would never again be matched. The light fell differently then. The sun, still young and burning with the fierce enthusiasm of early stellar life, cast its rays through an atmosphere rich with carbon dioxide and water vapor. The greenhouse embrace wrapped around the planet like a mother's arms, holding the warmth close, refusing to let it escape into the cold indifference of space. Temperatures held steady, comfortable, nurturing. The planet hummed with contentment. But even then, in those golden moments of Earth's adolescence, the signs were gathering like storm clouds on a distant horizon. Deep beneath the ocean floors, the planet's inner fire was growing restless. Tectonic plates, those vast puzzle pieces of rock and metal, had begun their eternal dance, grinding against each other, with movements so slow they could barely be called motion. Mountains rose and fell over millions of years like the breathing of some vast, slumbering giant. And in this geological ballet, something crucial was beginning to shift. The volcanoes that had once peppered the landscape with their fiery exhalations were growing quiet. One by one, the great mountains that had breathed carbon dioxide into the atmosphere were falling silent, their fires cooling, their voices fading to whispers. The delicate balance that had kept Earth's climate stable for countless eons was beginning to tip. Without the constant replenishment of greenhouse gases from volcanic activity, the atmosphere began its slow transformation. Carbon dioxide, that invisible blanket that had wrapped the planet in warmth, started to thin. The oceans, those vast reservoirs of life and chemistry, began to absorb more of the precious gas, pulling it down into their depths, where it would react with minerals and disappear from the air forever. The change was imperceptible at first, measured not in days or years but in millennia. The microbial mats continued their ancient work, unaware that their world was shifting beneath them. They photosynthesized with the same steady rhythm they had maintained for millions of years, converting sunlight and carbon dioxide into the building blocks of life, releasing oxygen as a waste product that few organisms of that era could even use. But the sun itself was changing too. Though it burned with nuclear fire that would last for billions of years, it was still young, still growing into its full strength. The light it cast was dimmer than the light that would one day nurture complex life, lacking the intensity that would be needed to maintain warmth in an atmosphere growing thinner by the century. The first hints of what was to come appeared not as dramatic events, but as subtle shifts in the rhythm of the world. Ocean currents, those great rivers of water that circulated heat around the globe, began to slow as temperature differences between the equator and the poles diminished. The constant mixing that had kept the planet's climate stable started to falter. Weather patterns, once predictable in their seasonal cycles, began to stutter and hesitate. Storms grew fewer and weaker. The winds that had carried moisture from the oceans to distant lands started to die down, leaving vast areas in an eerie calm that felt like the planet was holding its breath. In the shallow seas where the microbial mats had built their empires, the water began to cool by fractions of degrees that would have been unnoticeable to any conscious observer. But life, in its infinite sensitivity to change, began to sense that something was wrong. Growth slowed. Reproduction became more difficult. The great photosynthetic engines that had powered Earth's biosphere for so long started to run less efficiently as the chemistry of the oceans shifted. The planet was preparing for sleep, though it did not yet know it. The mechanisms that had maintained its warm, stable climate for hundreds of millions of years were beginning to fail, not through any catastrophic event, but through the slow, inexorable process of change that governs all things in the universe. High above, the stars looked down on this transformation with their usual indifference, their light unchanged since the beginning of time. They had seen worlds born and die, had watched as countless planets went through their own cycles of warmth and cold, life and death. To them, Earth was just another small world orbiting an ordinary star, unremarkable in its beauty, unremarkable in its struggle. But for Earth itself, the change was everything. The breath of the dying greenhouse was growing shallow, and with each exhalation, the planet moved one step closer to a silence that would last for millions of years. The Golden Age was ending, though the ending would take longer than mountains take to form, longer than oceans take to fill. It would be an ending measured in geological time, vast and patient and utterly implacable, like the turning of the universe itself. And in that turning, something unprecedented was about to begin. The sky began to weep ash. It started slowly, as all great transformations do, with volcanic eruptions scattered across the globe like candles guttering out one by one. But these were not the ordinary eruptions that had periodically refreshed Earth's atmosphere with life-giving carbon dioxide. These were different, violent, desperate exhalations of a planet in distress, shooting not just gas and lava into the air, but vast clouds of microscopic particles that would change everything. The ash rose in towering columns that pierced the atmosphere like grey spears thrust toward heaven. Each eruption sent billions of tiny fragments spinning into the sky, particles of rock and glass, so small they could float on the faintest breath of wind, so light they could circle the globe dozens of times before finally settling back to Earth. At first, the effect was beautiful in its strangeness. Sunsets became more vivid, painted in shades of orange and crimson that would have taken a human's breath away if humans had existed to see them. The ash scattered sunlight in new ways, creating halos around the sun and painting the sky in colors that had no names. The planet wore these clouds like a veil, delicate and ethereal, shimmering in the thin atmosphere. But beauty and destruction often wear the same face, and the ash clouds carried within them the seeds of catastrophe. The particles that danced so gracefully in the upper atmosphere had a terrible efficiency. They intercepted sunlight that had traveled 93 million miles through the vacuum of space, sunlight that had been meant to warm the oceans and nourish the microbial cities below. Instead of allowing this energy to reach the surface, the ash reflected it back into space, sending it on a journey into the cosmic dark from which it would never return. Day by day, the sky grew hazier. The sun, once a brilliant disk that had dominated the heavens, became a pale ghost of itself, barely visible through the thickening veil. Its light, when it did penetrate the clouds, took on a strange, silver quality that made everything below seem unreal, like a world viewed through frosted glass. Temperature began its slow, relentless descent. The change was measured first in fractions of degrees, fluctuations so small they might have been mistaken for normal variations in weather. But the trend was unmistakable. Each day was cooler than the last. Each week brought temperatures that hadn't been seen for thousands of years. Each month pushed the planet further into a realm of cold it had never experienced. The oceans, those vast reservoirs of heat that had moderated Earth's climate since the beginning of time, began to feel the first touches of a chill that would penetrate to their very depths. Surface temperatures that had remained stable for millions of years started to fluctuate wildly. The water that had once reflected the sky in perfect mirror images now lay grey and motionless, as if the seas themselves had lost the will to move. Ocean currents, those great circulation patterns that had carried warmth from the equator to the poles for countless eons, began to slow and stutter. The temperature differences that had driven these massive flows of water around the globe were diminishing as the entire planet cooled. What had once been a dynamic, ever-changing system of currents and countercurrents became sluggish and uncertain. The microbial mats that had carpeted the shallow seas for so long began to sense the change in ways that defied explanation. Though they possessed no nervous systems, no brains to process information, they responded to the cooling waters with something that resembled panic. Growth slowed to a crawl. The elaborate chemical processes that had sustained them for millions of years became less efficient as enzymes struggled to function in the decreasing temperatures. Entire colonies began to die, their carefully constructed towers and domes crumbling as the organisms that had built them succumbed to the cold. Where once there had been vibrant ecosystems teeming with microscopic life, empty shells and mineral skeletons began to accumulate on the ocean floor like the ruins of abandoned cities. The ash continued to fall, settling on the surface of the seas in layers so thin they were almost invisible, yet dense enough to alter the chemistry of the water itself. The particles carried with them traces of sulfur and other chemicals that reacted with seawater to form acids weak enough to be harmless individually, but collectively capable of disrupting the delicate balance that had sustained marine life for so long. Weather patterns that had remained stable for geological ages began to break down entirely. The great monsoons that had brought seasonal rains to vast continents simply stopped, leaving behind skies so clear and empty they seemed to stretch into infinity. Clouds, when they did form, hung low and grey, producing rain that fell cold and bitter, carrying with it the taste of the dying sky. Winds that had once carried warmth and moisture across thousands of miles grew fitful and uncertain. Sometimes they would blow with sudden violence, stirring up dust storms that darkened the already dim daylight. Other times they would die away completely, leaving the air so still that even the smallest sounds seemed to echo forever. The planet was entering a new phase of its existence, though the change was so gradual that it might have seemed like a natural fluctuation to any observer. But this was no ordinary climate shift. This was the beginning of a transformation, so profound it would reshape not just the surface of the world, but the very definition of what it meant for a planet to be alive. High in the atmosphere, the ash clouds continued their deadly work, growing thicker with each passing eruption, reflecting more and more sunlight back into space. The planet was dimming like a candle being slowly snuffed out, its warmth leaking away into the cosmic cold 1 degree at a time. And in the depths of space, the stars looked down on this transformation with their eternal silence, witnesses to the beginning of the longest winter in Earth's history. The world was learning to shiver. Water remembers everything. In the rivers that had flowed for millions of years, carrying nutrients from mountain to sea, in an endless cycle of renewal, the first crystals began to form. They appeared at the edges first, in the quiet places, where current moved slowly, and the cold could take hold tiny geometric flowers of ice that bloomed in the pre-dawn darkness and melted away when the sun climbed higher in the ash-veiled sky. But each day, the flowers lasted a little longer. The great rivers that had carved continents and filled oceans began to hesitate in their eternal journey toward the sea. Ice formed in their shallows, delicate at first, fragile as spun glass, yet carrying within its crystalline structure a terrible patience. The cold was learning the landscape, finding every hollow and depression where water pooled, every quiet eddy where the flow slowed enough for transformation to begin. Rain, when it fell, no longer brought life to the land. Instead, it came as needles of ice that struck leaves and stone with sounds like breaking glass. Each droplet that descended from the grey sky carried within it the blueprint of winter, the molecular memory of a world growing colder with each passing season. In the shallow pools where microbial mats had once thrived, building their tiny empires one cell at a time, the water began its surrender to the cold. These oases of life, scattered across the planet like green jewels in a brown landscape, had survived every catastrophe that Earth had thrown at them for hundreds of millions of years. They had weathered asteroid impacts and volcanic eruptions, had adapted to changes in atmosphere and ocean chemistry with the resilience that only the simplest forms of life possess. But they had never faced anything like this. The first frost came on a morning when the sun rose pale and distant through clouds that seemed made of pewter rather than water vapor. The temperature had dropped during the night to levels that these ancient organisms had never experienced, levels that pushed the chemistry of life itself to its breaking point. Ice formed on the surface of the pools in patterns that would have been beautiful if they had not been so deadly. Geometric designs spread across the water like living mandalas, each crystal connecting to the next in fractal patterns that seemed to follow some hidden mathematical law. The ice was thin at first, barely a membrane between water and air, but it was enough to begin the process that would transform everything. Beneath the ice, the microbial mats felt the change as a slowing in their most fundamental processes. Photosynthesis, that ancient alchemy that had powered life on Earth since the beginning, became sluggish and inefficient as enzymes struggled to function in the dropping temperatures. Chemical reactions that had proceeded with clockwork precision for millions of years began to falter and fail, but the microbes did not surrender easily. In their simple, determined way, they began to fight back against the cold. Some species started producing antifreeze proteins, molecular bodyguards, that could prevent ice crystals from forming within their cells. Others shifted their metabolism, burning stored energy at higher rates to generate heat. Still, others began to change their very chemical composition, altering the balance of fats and proteins in their cell membranes to remain flexible in the freezing temperatures. For a time, it seemed as though life might find a way to adapt, as it had adapted to every previous challenge. The pools continued to function, though less efficiently than before. The great cycles of photosynthesis and respiration continued, though at a slower pace. The planet's first ecosystems hung on with desperate tenacity, refusing to let go of the world they had inherited. But the cold was relentless, and it was accelerating. Each night brought lower temperatures than the night before. Each dawn revealed new expanses of ice, where there had been liquid water the evening before. The frost no longer melted completely during the brief, dim days. Instead, it accumulated, building up in layers that trapped more cold within their crystalline structures. The moment came without warning or ceremony, a morning when the sun rose to find that frost had spread across the entire surface of the planet like a silver web. Every pool, every stream, every temporary puddle left by the increasingly rare rains was touched by ice. The transition point had been crossed, the threshold beyond which there could be no easy return. Sunlight, already weakened by the ash clouds that continued to veil the sky, now encountered a new enemy. The frost reflected light with an efficiency that the volcanic particles could never have matched. Where once the sun's rays had been absorbed by dark water and living organisms, warming the surface and sustaining life, now they bounced back into space like arrows shot at a mirror. The albedo effect had begun that deadly feedback loop where cooling creates more ice, and more ice creates more cooling. Each new patch of frost reflected sunlight that might have warmed the planet, instead sending that energy on a one-way journey into the cosmic dark. The Earth was becoming its own enemy, using the very mechanics of physics to accelerate its descent into cold. Weather patterns that had already been disrupted by the volcanic ash now collapsed entirely. The temperature differences between day and night, between equator and poles, began to even out in the most ominous way possible, not by the tropics cooling slightly, but by everywhere becoming equally cold. The great atmospheric circulation patterns that had driven winds around the globe for geological ages simply stopped working as the energy that powered them disappeared. In the oceans, surface waters that had resisted freezing for so long began to form the first tentative sheets of sea ice. These were different from the river ice, thicker and more persistent, floating on the surface like white islands in the grey sea. Each new ice sheet reflected more sunlight, accelerated the cooling, created conditions for more ice to form. The planet was learning to freeze, and it was a fast learner. High above, the stars looked down on this transformation with their usual indifference. They had seen ice ages before, on other worlds, orbiting other suns. But even by cosmic standards, what was happening to Earth was unusual in its speed and completeness. This was not a gradual cooling that would claim the poles and work its way toward the equator over millions of years. This was something far more dramatic, a worldwide surrender to winter that was happening in geological time, which is to say, almost instantaneously. The first frost had been a warning. Now came the deluge of ice, spreading across the planet's surface like a contagion of cold, transforming everything it touched into a crystalline memorial to warmth that would soon be nothing but memory. The planet held its breath, and that breath came out as clouds of ice that would not melt for millions of years. The world had become a lens, focusing cold instead of light. Across the surface of the planet, ice spread with the patient inevitability of a mathematical proof. What had begun as scattered patches of frost in quiet pools and slow rivers had become something far more profound. A transformation so complete that the very definition of Earth's surface had changed. Where once there had been blue oceans and brown continents, green forests and grey deserts, now there was only white. White that stretched from horizon to horizon. White that reflected the pale sun like a million scattered diamonds. White that grew thicker and more perfect with each passing day. The oceans, those vast reservoirs of heat that had moderated the planet's climate since the beginning of time, were surrendering to the ice, mile by mile. It began at the poles, where the sun's rays had always been weakest, and winter had always held the strongest grip. Sea ice formed in massive sheets that groaned and cracked as they expanded, producing sounds that echoed across the empty landscape, like the breathing of some vast, sleeping creature. But this ice was different from anything that had come before. Instead of forming the thin, seasonal layers that appeared and disappeared with the turning of the year, it grew thick and permanent, accumulating layer upon layer until it became a solid barrier between the ocean and the sky. The water beneath remained liquid for a while, warmed by heat rising from the planet's interior, but even this refuge was temporary. The albedo effect, that deadly feedback loop that had begun with the first frost, was now accelerating beyond anything the planet had ever experienced. Each new square mile of ice reflected sunlight that might have provided warmth, instead sending that energy careening back into space, where it would wander forever among the stars. The Earth was becoming a mirror pointed at the sun, a cosmic reflector that deflected the very energy it needed to survive. From space, the transformation would have been visible as a spreading whiteness that began at the poles and crept toward the equator, with inexorable purpose. Continents disappeared beneath ice sheets that grew thick enough to bury mountains. Ocean currents, those great circulation patterns that had carried heat around the globe for hundreds of millions of years, slowed to a crawl, and then stopped entirely as the temperature differences that powered them vanished into uniformity. The ice was not uniform in its conquest. It sculpted the landscape as it advanced, carving valleys and polishing stone with the infinite patience of frozen water under pressure. Glaciers flowed like slow rivers of crystal, following the path of least resistance, filling every depression and smoothing every irregularity until the surface of the world became a seamless expanse of white. In places where the ice was thin, the wind carved it into fantastic shapes, ridges and valleys, towers and canyons that rose and fell like the architecture of some alien civilization. These ice formations caught and scattered sunlight in complex patterns that painted the landscape in subtle shades of blue and silver, creating beauty on a scale that no living thing remained to witness. The few pockets of life that had managed to survive the initial cooling found themselves trapped in an increasingly hostile world. In the deepest parts of the oceans, where volcanic vents still released heat from the planet's interior, tiny communities of organisms clung to existence in water that remained just barely liquid. These survivors, descendants of the microbial mats that had once covered vast areas of the seafloor, had been reduced to refugees huddling around the last sources of warmth on a freezing planet. But even these final refuges were being systematically eliminated as the ice grew thicker and pressed down on the oceans with the weight of continents. The pressure from above forced seawater up through cracks in the ice, where it froze instantly in the supercooled air, sealing the openings and cutting off the exchange of gases that the deep-sea communities needed to survive. Weather, as Earth had known it for billions of years, simply ceased to exist. The complex interplay of temperature differences that had driven winds and storms around the globe was replaced by a deadly uniformity. Temperatures at the equator and the poles converged on the same bitter cold. The atmosphere, what remained of it, became still and thin, unable to support the vast circulation patterns that had once carried moisture and heat across continents. When wind did blow, it carried only ice crystals and the memories of storms that would never come again. These winds carved the surface of the frozen planet into flowing patterns that resembled frozen waves, creating a landscape that seemed to preserve the motion of ancient tempests in crystalline perfection. The sun, still burning with nuclear fire 93 million miles away, continued to shine on this transformed world, but its light had become almost irrelevant. The planet that had once absorbed its warmth now rejected it completely, reflecting the life-giving energy back into space with an efficiency that bordered on the supernatural. Earth had become a cosmic snowball, bright and cold and utterly lifeless on its surface. Deep beneath the ice, in the planet's core, nuclear decay continued to generate heat just as it had for billions of years. This warmth, trapped beneath miles of frozen water, created a hidden ocean that would remain liquid throughout the freeze. But this ocean was cut off from the surface world completely, sealed away from sunlight and atmosphere, a secret sea that would harbor what little life remained through the long winter to come. The transformation was nearly complete. From the deepest trenches of the ocean floor to the highest peaks of the mountains, everything was covered in ice. The planet's surface had become a single, continuous sheet of white that stretched unbroken from pole to pole. Earth had achieved a kind of perfection, the perfect reflection of sunlight, the perfect preservation of cold, the perfect silence of a world where motion and change had been suspended by the absolute authority of ice. High above, auroras danced in the thin atmosphere, painting the sky in ghostly sheets of green and gold that no eye would see. These lights, caused by solar particles interacting with the planet's magnetic field, had become the only movement in a world that had forgotten how to move. They flickered and swayed like the dreams of a sleeping planet, beautiful and pointless in their cosmic solitude. The shattered mirror of Earth's surface reflected not just sunlight, but time itself, freezing moments into crystal, preserving the memory of warmth in patterns of ice that would endure for millions of years. The planet had become its own monument, a crystalline memorial to the age of life that had ended not with fire or collision, but with the quiet, inexorable triumph of cold. In the cosmic dark beyond the solar system, other stars burned with their own nuclear fires, warming other worlds that might be experiencing their own golden ages of life and warmth. But Earth was no longer one of them. Earth had become something new, a frozen archive of what had been, spinning through space like a white jewel in the darkness, carrying within its ice the compressed history of a world that had once been alive. The world slept. In the end, it was the silence that claimed everything, not the cold, though that had done its work with brutal efficiency. Not the ice, though it had sealed away every trace of the world that had been. It was the silence that fell over the planet like a benediction, complete and perfect and eternal, wrapping the frozen earth in a quietude so profound that sound itself seemed to have forgotten how to exist. The atmosphere, what remained of it, had become thin as whispers. Most of the water vapor that had once filled the air with life-giving humidity had condensed and frozen, joining the miles-thick ice sheets that now covered every ocean and continent. The carbon dioxide that had once warmed the planet through its greenhouse embrace had been absorbed into the ice or locked away in the depths of the frozen seas. What little air remained was cold beyond the comprehension of any living thing, cold enough to freeze the breath of gods. From space, Earth appeared transformed beyond recognition. The blue marble that had once hung in the cosmic dark like a beacon of life had become something else entirely, a perfect sphere of white that reflected the light of the sun with mirror-like precision. No clouds marred its crystalline surface, no weather systems swirled across its frozen face. It was a planet reduced to its purest essence: ice and silence, and the slow, patient turning that carried it around its star in an orbit that had become meaningless. The ice itself had achieved a kind of perfection that was terrible in its beauty. Miles thick in places, it had flowed and settled into forms that followed the hidden mathematics of crystalline structure. Pressure and time had worked together to create layers upon layers of frozen water, each one preserving a moment in the planet's descent into cold. Deep within this ice, trapped like insects in amber, were the remains of the last living things, microbial mats, and primitive organisms that had been flash-frozen in the final moments of their existence, their cellular structures preserved in crystalline perfection for epochs to come. The surface of this ice world was carved into formations that seemed to echo with the memory of motion. Wind, in the final days before the atmosphere became too thin to support it, had sculpted ridges and valleys that flowed across the landscape like frozen rivers. These formations caught and scattered the pale sunlight in patterns that created an optical symphony, though there were no eyes to see it, no consciousness to appreciate the mathematical beauty of light dancing across infinite fields of white. In the depths beneath the ice, the hidden ocean remained liquid, kept warm by the slow, radioactive decay of elements in the planet's core. This secret sea, cut off from the surface world completely, had become the repository of everything that remained of Earth's biological heritage. Here, in the absolute darkness of the deep, a handful of organisms survived on the chemical energy released by underwater volcanic vents. They were the last guardians of life on a world that had forgotten what life meant, clinging to existence in conditions that made the surface of an alien moon seem hospitable by comparison. These survivors knew nothing of the world above them. They had never seen sunlight, had never experienced the rhythm of day and night, had never felt the touch of wind or rain. They existed in a realm of pure chemistry, where survival depended not on the complex interactions of ecosystems, but on the simple ability to extract energy from sulfur compounds and mineral-rich water. They were life reduced to its absolute minimum chemical reactions that had achieved the curious property of self-replication and the stubborn determination to continue existing despite everything the universe could throw at them. The silence that reigned over this frozen world was not merely the absence of sound, it was the absence of change itself. Without wind to carve new patterns in the ice, without weather to erode and reshape the surface, without the breath of living things to alter the chemistry of the atmosphere, the planet had entered a state of crystalline permanence. Time passed. The Earth continued its orbit around the Sun. The stars continued their slow dance across the cosmic dark, but the passage of time left no mark on the frozen surface. Each day was identical to the last. Each year, a perfect repetition of the year before. The sun rose and set over this ice world with mechanical precision, its light growing no warmer, its rays finding no purchase on the reflective surface below. The solar energy that had once powered vast ecosystems and driven the circulation of oceans and atmosphere now bounced back into space, almost completely, sending the gift of a star back into the void, where it would wander forever among distant galaxies. Seasons, those ancient rhythms that had marked the passage of time since the formation of the solar system, became meaningless. Winter was eternal, summer was a memory locked in ice, and the slight variations in Earth's distance from the sun made no difference to a world where all heat was reflected away before it could take hold. The moon continued its eternal dance around the frozen planet, raising tides in the hidden ocean beneath the ice. But these movements were felt only in the deepest places where water still flowed. The surface remained unmoved, unmoving, a crystalline shell that had forgotten how to respond to the gravitational pull of its satellite. In the cosmic perspective, Earth had become a cautionary tale written in ice and silence. Other worlds, orbiting other stars, might look upon it as a warning of what could happen when the delicate balance that sustains life is disturbed. But more likely, they would not notice it at all. The universe is vast and largely indifferent to the struggles of individual planets, and a frozen world orbiting a small yellow star was hardly remarkable among the countless wonders and tragedies that played out across the cosmos. The great silence settled deeper with each passing millennium, seeping into the very structure of the ice itself, becoming part of the planet's identity. This was no longer the Earth that had harbored life, that had known the sound of wind and water and the quiet persistence of growing things. This was something new, a crystalline memorial to warmth, a frozen museum of a world that had once been alive. And in that silence, profound and complete, the planet began the longest sleep in its history. It would dream, perhaps, of the warmth it had known, of shallow seas and microbial cities, of the time when its surface had moved and changed and responded to the touch of sunlight. But those dreams would be locked away beneath miles of ice, preserved in the darkness of the hidden ocean, waiting for a resurrection that might never come. The world slept, and in its sleeping, it changed the very definition of what it meant to be a planet. It had become a testament to the power of silence, a proof that even worlds could learn to hold their breath for millions of years. The stars looked down on this transformation with their usual cosmic indifference, but perhaps, in their ancient light, there was something that might have been mistaken for sadness. Or perhaps it was simply the cold reflection of starlight on a world that had forgotten how to shine with warmth. The world slept, deep, deeper than mountains are tall, deeper than light could ever penetrate, in the secret places where Earth's heart still beat with the slow pulse of radioactive decay. Warmth endured. Here, in the hidden ocean that lay trapped between the planet's molten core and the miles of ice that had become its ceiling, life had learned to whisper instead of sing. The water moved in currents so slow they could barely be called motion, stirring with the rhythm of geological time, carrying heat from volcanic vents across the lightless seafloor like blood through the veins of a sleeping giant. In this realm beneath the eternal night, the rules of existence had been rewritten in the vocabulary of extremes. Temperature was measured not in the comfortable ranges that had once nurtured surface life, but in the narrow band between freezing death and scalding dissolution. Pressure squeezed every molecule of water with the weight of continents, creating conditions that would have crushed any surface dweller in an instant. Yet life persisted. Around the thermal vents that rose from the ocean floor like chimneys breathing the planet's inner fire, colonies of microorganisms had gathered in communities, so ancient they predated the Ice Age by hundreds of millions of years. These were the descendants of Earth's first children, the chemical pioneers who had learned to extract energy from the marriage of heat and mineral, who had discovered the secret of transforming sulfur and iron into the stuff of existence. They built their cities on the surfaces of rocks, spreading in thin films that caught and concentrated the precious chemicals flowing from the vents. Each colony was a masterpiece of cooperation, billions of individual cells, working together with a coordination that bordered on consciousness. They shared nutrients with the generosity of organisms that understood scarcity, passed genetic information between species with the fluidity of a communal mind. The heartbeat of their existence was slow, measured in days rather than minutes, in seasons rather than hours. They had adapted to the rhythm of the deep earth, where change came, not with the rising and setting of the sun. There was no sun here, but with the irregular pulse of volcanic activity, the slow circulation of mineral-rich water, the gradual shift of chemical gradients that marked the passage of time in this buried world. Some had learned to harvest energy from the breakdown of hydrogen sulfide, that poisonous gas that bubbled up from the planet's interior, like the breath of sleeping dragons. Others fed on methane, on ammonia, on chemical compounds that would have been deadly to the surface life that had once dominated the planet. They had become alchemists of the impossible, transforming toxins into sustenance with the patient efficiency of organisms that had nowhere else to go. Their genetic code carried within it the memory of sunlight, though none of them had ever experienced its touch. Deep within their cellular machinery lay the blueprints for photosynthesis, for the complex chemistry that could transform light into life. But these molecular fossils remained dormant, vestigial remnants of an evolutionary past that had become irrelevant in a world where the only light came from the occasional bioluminescent display of organisms, creating their own illumination through chemical reactions. The water around them moved with currents driven not by wind or weather, but by the deep circulation patterns of a hidden ocean. Warm water rose from the vents, carrying with it dissolved minerals and gases that had been processed in the furnaces of the Earth's interior. This water spread across the seafloor, cooling gradually as it moved away from its source, eventually sinking back into the depths to begin the cycle again. In this circulation, life found opportunity. Organisms that lived near the vents specialized in high-temperature chemistry. Their proteins and enzymes evolved to function in water that would have boiled on the surface. Others adapted to the cooler zones, developing metabolisms that could function efficiently in the intermediate temperatures found in the mixing zones where warm and cool currents met. The diversity that emerged in this hidden realm was astonishing in its subtlety. To the untrained eye, these might have appeared to be simple communities of bacteria and archaea, primitive life forms barely distinguishable from one another. But each species was a unique solution to the puzzle of existence in this extreme environment, a distinct approach to the challenge of extracting energy and materials from the limited resources available in the deep ocean. Some had developed the ability to sense magnetic fields, using the Earth's electromagnetic signature to navigate in the absolute darkness. Others had evolved chemical communication systems of remarkable sophistication, sending molecular messages across vast distances to coordinate the activities of their communities. Still, others had learned to manipulate their environment, building structures from precipitated minerals that could channel water flow and concentrate nutrients. The volcanic vents themselves were ecosystems in miniature, each one a unique world shaped by the specific chemistry of the water that flowed from it. Some vents produced water rich in sulfur compounds, supporting communities of sulfur-oxidizing bacteria that painted the rocks in brilliant yellows and oranges, colors that existed in perfect beauty, despite the fact that no eye would ever see them. Others released water heavy with iron, creating rust-red formations that housed species specialized in iron metabolism. These communities existed in a delicate balance with their environment, dependent on the continued activity of the vents that sustained them. When a vent died, cooling, as the geological forces that drove it shifted or weakened, the community around it would slowly starve and disperse. But new vents opened regularly as the Earth's crust continued its slow dance of expansion and contraction, creating new opportunities for life in the endless darkness. The pressure of the deep ocean had become an ally rather than an enemy, helping to stabilize the complex molecular structures that these organisms had evolved. Proteins that would have unfolded and become useless at the surface maintained their shape and function in the crushing depths, while metabolic processes that required precise molecular interactions proceeded with clockwork regularity in the still, dense water. Time moved differently in this hidden world. Without the rhythms of day and night, without seasons or weather, the passage of years was marked only by the slow changes in water chemistry, the gradual shift of geological formations, the patient accumulation of genetic mutations that would, over millions of years, guide evolution toward forms of life that the surface world had never imagined. These organisms were living proof that life could adapt to almost any conditions, could find ways to persist in environments that seemed utterly hostile to existence. They were the guardians of biological possibility, keeping alive the potential for complexity and diversity in a world that had seemingly surrendered to the simplicity of ice and silence. In the vast darkness of the hidden ocean, surrounded by water that had not seen sunlight for millions of years, these communities continued their ancient work of transforming simple chemicals into the complex molecules of life. They were the breath beneath the ice, the whispered promise that even in the deepest winter, the spark of existence could continue to burn. They waited, with the infinite patience of organisms that had learned to measure time in geological epochs, for the world above to remember how to live. Silence had weight. In the crushed spaces between ice and stone, where the hidden ocean pressed against the roof of its crystalline prison, darkness had become so complete. It seemed solid, tangible, something that could be touched and tasted and breathed. This was not the darkness of night, which carried within it the promise of dawn. This was the darkness of burial, of spaces sealed away from the universe of light forever. The ocean had been vast once, when it could spread across the surface of the planet and breathe with the atmosphere above. Now it was compressed, squeezed into the space between the frozen ceiling and the rocky floor, a layer of liquid life sandwiched between two forms of death. The pressure here was beyond anything the surface world had ever known, the accumulated weight of miles of ice, pressing down with the force of tectonic plates. creating conditions that transformed water into something denser, stranger, more reluctant to move. Yet move it did, in currents so slow, they seemed more like the circulation of stone than liquid. These deep flows carried whispers between communities of organisms separated by hundreds of miles, molecular messages that took years to travel from sender to receiver. The ocean had become a vast, slow-thinking mind, its thoughts expressed in chemical gradients and temperature variations that pulsed through the water, like synapses firing in a brain made of minerals and microbes. The biosphere had been reduced to embers, scattered sparks of life glowing in the cosmic dark. Where once there had been vast ecosystems spanning continents, now there were only isolated pockets of organisms clustered around the thermal vents that provided the only reliable sources of energy in this buried world. These communities existed like islands in a sea of emptiness, each one a universe unto itself, developing in isolation from its neighbors. Between these islands of life lay expanses of water, so barren they might as well have been vacuum. Here, in the spaces too far from any vent to benefit from its chemical largesse, the ocean was reduced to its most basic elements, water molecules, moving in slow thermal motion, carrying dissolved minerals in concentrations so low they barely registered as chemistry rather than physics. But even in these empty spaces, life found ways to persist. Free-floating organisms had learned to harvest energy from the breakdown of organic molecules that drifted down from the more productive areas around the vents. They lived like scavengers in a vast graveyard, feeding on the molecular remains of their more fortunate cousins, extracting every available calorie from compounds that had already been processed dozens of times by other organisms. The evolution of cooperation in this constrained environment had reached levels of sophistication that bordered on the supernatural. Organisms that might have competed in a world of abundance instead shared everything: nutrients, genetic material, even metabolic processes. Entire communities functioned as single superorganisms, their individual members so specialized that they had lost the ability to survive independently. Chemical communication had evolved into an art form of molecular poetry. Organisms sent messages encoded in complex organic compounds, sentences written in the grammar of amino acids and sugars that could convey information about nutrient availability, danger, reproductive status, and even something that might have been mistaken for emotion if such concepts could apply to creatures without nervous systems. The smell of sulfur and iron filled the water like incense in a cathedral, the aromatic signature of chemical processes that had learned to substitute for photosynthesis in a world without light. These compounds created gradients that organisms could follow like breadcrumbs, chemical highways that led from barren areas to the oases around active vents. Some species had developed bioluminescence, the ability to create their own light through chemical reactions that converted stored energy into brief flashes of blue-green radiance. These displays served multiple purposes: communication, predation, defense, but they also added an element of ethereal beauty to the darkness. Like fireflies in a forest, these deep-sea organisms created patterns of light that flickered and pulsed through the water, writing temporary stories in photons that would be absorbed and forgotten within seconds. The architecture of life in the deep ocean had been forced to become three-dimensional in ways that surface ecosystems had never needed to explore. With no solid surfaces except the seafloor and the occasional chunk of volcanic rock, organisms had learned to build their communities in the water column itself, creating floating cities held together by chemical bonds and cooperative behavior. These structures were invisible to any observer, existing as they did in the form of chemical gradients and population densities, rather than physical construction. But they were real, nonetheless organized, persistent, capable of growth and adaptation. They represented a form of engineering that used biology itself as building material, creating stable ecosystems that could persist for millions of years without any solid foundation. The thermal layering of the water had created distinct zones, each with its own community of organisms adapted to specific temperature ranges. Near the seafloor, where volcanic heat was strongest, Thermophilic bacteria thrived in conditions that would have been lethal to most life forms. Higher in the water column, where temperatures moderated, more familiar forms of microbial life pursued metabolisms based on the processing of organic compounds and dissolved minerals. At the highest levels of the ocean, just below the ice ceiling, psychrophilic organisms had evolved to function in water so cold it was barely liquid. These communities existed at the very edge of possibility. Their metabolism slowed to a crawl, their reproduction measured in decades rather than days. They were the scouts of life, the organisms that tested the boundaries of what was possible in this frozen world. The ice ceiling itself had become a unique habitat, its lower surface colonized by organisms that had learned to extract nutrients from the frozen water above them. They secreted antifreeze compounds that created tiny pockets of liquid in the solid ice, microscopic caverns, where they could live and reproduce in conditions that existed nowhere else in the known universe. Time in the prisoned ocean moved like honey, thick and slow and golden with dissolved minerals. Generations of organisms lived and died in the span of what would have been moments in the surface world's former glory. Evolution proceeded at its own pace, unhurried by the need to adapt to changing seasons or weather patterns that no longer existed. In this compressed universe of water and darkness, life had learned to speak in whispers, to live on less, to find meaning in the simple persistence of existence itself. The ocean had become a library of possibility, its volumes written in genetic code and stored in the cells of organisms that carried within them the memory of what life could become when the world above learned to live again. The darkness pressed close, but it could not extinguish the embers. In the depths of the prisoned ocean, life continued its ancient conversation with chemistry, writing new chapters in the story of what it meant to exist in a universe that seemed determined to return everything to silence and cold. The first sound in a million years was the crack of ice breaking. Deep beneath the frozen surface, where the planet's interior heat had been building pressure like a slow-breathing volcano, something stirred. The Earth's core, still burning with the nuclear fire of its formation, had never acknowledged the ice age that gripped its surface. It continued its ancient work of radioactive decay, generating heat that had nowhere to go but up, pressing against the frozen ceiling of the world with patient, inexorable force. The crack, when it came, was both violent and subtle, a fracture that split miles of ice in a matter of seconds, yet produced a sound so deep and resonant it took hours to propagate through the solid water. The noise echoed through the hidden ocean like the groan of a waking giant, the first percussion in a symphony that had been silent for geological ages. Through the crack came something unprecedented. Volcanic ash mixed with superheated steam, the exhaled breath of the planet's molten interior finally finding a path to the surface. This was not the gentle, life-giving warmth that had once characterized Earth's climate, but something raw and primal heat born in the heart of the world, carrying with it minerals and chemicals that had been processed in furnaces no surface organism had ever experienced. The ash fell through the water like black snow, each particle a tiny messenger from the depths of the Earth. Unlike the ash that had helped trigger the Ice Age millions of years before, this volcanic dust carried a different message. Where it settled on the seafloor, it brought not cooling, but warmth, microscopic grains of mineral matter that absorbed and concentrated heat, creating pockets of elevated temperature in the frigid darkness. For the first time since the ice had claimed the world, conditions began to change. The organisms that lived near the thermal vents felt the shift first, sensing through mechanisms refined over millions of years of evolution the subtle alterations in water chemistry that indicated new possibilities. Nutrients that had been locked away in the ice began to dissolve into the water as the ash created localized warming. Chemical gradients that had remained stable for epochs started to shift and flow, carrying with them the promise of new energy sources. Near the cracks in the ice, where volcanic heat could reach toward the surface, something extraordinary began to happen. The perpetual darkness was punctuated by the faintest possible glow, not the bioluminescence of deep-sea organisms, but actual light filtering down from above. It was dim beyond description, barely more than a theoretical brightness, but for organisms that had evolved in absolute darkness, it might as well have been the blazing radiance of a star. This light, weak as it was, awakened genetic pathways that had been dormant for millions of years. Deep within the cellular machinery of certain organisms, the molecular blueprints for photosynthesis began to stir. These were evolutionary fossils, genetic sequences that had been preserved through the long winter, not because they served any current purpose, but because the cost of maintaining them was so low that natural selection had never bothered to eliminate them. Now, suddenly, they had value again. The first attempts at photosynthesis in this new environment were crude, inefficient processes that captured only a tiny fraction of the available light. But even this minimal energy harvest was enough to supplement the chemosynthetic metabolism that had sustained life through the Ice Age. Organisms that had survived on the edge of starvation for millions of years suddenly found themselves with access to an additional energy source. The evolutionary response was swift by geological standards, glacial by any other measure. Populations that had remained stable for millions of years began to grow and diversify. Genetic mutations that had been neutral or slightly harmful in the dark ocean suddenly became advantageous when they improved an organism's ability to capture and use light. The ash continued to fall, creating a complex chemical environment that organisms began to explore with the tentative curiosity of life discovering new possibilities. Some particles contained iron compounds that could be used to improve the efficiency of photosynthetic processes. Others carried sulfur and phosphorus, essential nutrients that had been in short supply in the barren deep ocean. Around the thermal vents, where volcanic activity was strongest, entirely new communities began to form. These were hybrid ecosystems that combined the ancient chemosynthetic metabolism of the vent organisms with the emerging photosynthetic capabilities of the organisms adapting to the trace amounts of light. The interaction between these two energy sources created a complexity that the deep ocean had not seen since the Ice Age began. The ice itself was changing. The heat from below, combined with the warming effect of the dark ash that accumulated on its surface, began to create pockets of partially melted water within the solid mass. These liquid inclusions became new habitats, microscopic worlds where organisms could live in conditions intermediate between the crushing pressure of the deep ocean and the solid imprisonment of the ice. Evolution in these marginal environments proceeded along paths that surface life had never explored. Organisms developed the ability to survive in water that was simultaneously liquid and solid, existing in a phase state that defied conventional understanding. They learned to extract nutrients from ice itself, processing the trace minerals that had been frozen into the crystalline structure of the water. The chemical signature of the ash created new forms of cooperation between species. Organisms that had evolved in isolation began to encounter chemicals that served as molecular messengers from distant communities. These chemical communications, carried by the slow currents of the deep ocean, enabled coordination between populations separated by hundreds of miles. Hope, if such a concept could apply to organisms without consciousness, began to stir in the darkness. The change was barely perceptible, measured in parts per million of chemical concentration and fractions of degrees of temperature increase. But it was change nonetheless, the first deviation from the static conditions that had prevailed for millions of years. The volcanic activity was not a rescue, not a return to the warm world that had existed before the ice. It was something smaller and more precious, a crack in the wall of impossibility, a demonstration that the universe could still surprise itself, could still find ways to alter conditions that had seemed permanent and unchangeable. In the deepest trenches of the hidden ocean, where pressure and darkness had created a realm beyond the reach of any surface phenomenon, organisms that had never known anything but extremity began to sense that their universe was expanding. The molecules they absorbed carried new flavors, new possibilities, new combinations of elements that suggested their world might be larger and more complex than they had evolved to comprehend. The ash settled like black snow on a world that had forgotten snow could be anything but white, and in that settling, it carried with it the first whispered promise that winter, no matter how long, no matter how deep, was not necessarily eternal. Something was stirring beneath the eternal night, and for the first time in millions of years, that something was not just survival, but change. In the margins between death and persistence, evolution learned to whisper new words. The volcanic ash had been falling for thousands of years now, accumulating in layers on the sea floor like sediments of possibility. Where it settled thickest, around the cracks in the ice where heat could escape most efficiently, the temperature had risen just enough to cross crucial thresholds. Not warmth, as the surface world had once known it, but something measurably different from the absolute cold that had reigned for so long. These tiny oases of relative warmth had become laboratories of transformation, places where the slow work of evolution could proceed under conditions that hadn't existed since the ice claimed the world. The organisms that gathered in these spaces were no longer simply surviving. They were beginning to experiment with new forms of existence. The first breakthrough came not from innovation, but from cooperation. They, Aus, Chapter 2c, 2. In the crushing darkness of the deep ocean, where resources were scarce and energy was precious, competition had always been a luxury that life could not afford. But now, with slightly more energy available from the combination of chemical and photosynthetic processes, organisms began to explore forms of collaboration so intimate they bordered on fusion. It began with simple symbiosis, one organism living inside another, each providing something the other needed. A photosynthetic bacterium would take up residence within the cell of a larger organism, offering energy from the trace amounts of light in exchange for protection and nutrients. But what started as a temporary arrangement gradually became something more permanent, more profound. The boundaries between organisms began to blur. Genetic material flowed between species, with unprecedented freedom, creating chimeric beings that combined the metabolic pathways of multiple lineages. What had once been separate species became components of larger, more complex systems, living libraries, where the evolutionary wisdom of millions of years was pooled and shared. The first true multicellular organisms emerged from this genetic mingling like sculptures carved from shadow. They were barely visible even to the most sophisticated microscope, clusters of cells so small they could have hidden in the period at the end of this sentence. But they represented a revolution in the organization of life itself, the transition from single-celled independence to cooperative complexity. These early multicellular pioneers were unlike anything that had existed during the warm ages before the ice. They had evolved under conditions of extreme scarcity, where every molecule of energy had to be conserved and every cellular process had to serve multiple functions. The result was an efficiency of design that bordered on the mathematical organisms, that wasted nothing, that found ways to extract value from the most marginal conditions. Their reproduction was an act of careful calculation rather than biological exuberance. Instead of the rapid, exponential growth that had characterized surface life, these organisms divided slowly, deliberately, passing down not just genetic information but complex chemical instructions that could only be maintained through generations of careful copying. Each new organism was a repository of survival strategies, refined over millions of years of existence, at the edge of possibility. Communication between these early multicellular organisms developed along pathways that surface life had never explored. They exchanged chemical messages of remarkable sophistication, molecular sentences that could convey information about nutrient availability, environmental conditions, and even the genetic status of potential reproductive partners. These communications created networks of information flow that spanned vast distances in the hidden ocean. The pressure of the deep environment had unexpected benefits for cellular organization. Proteins that would have been unstable in the lower pressures of surface conditions held their shapes with crystalline precision in the crushing depths. Cellular membranes became stronger and more selective, able to maintain complex chemical gradients that enabled new forms of metabolism. Some of these organisms developed the ability to sense and respond to magnetic fields, using the Earth's electromagnetic signature to navigate in the absolute darkness. Others evolved chemical senses so acute they could detect single molecules of specific compounds in vast volumes of water, following chemical trails like bloodhounds tracking scents that existed only in parts per trillion. The volcanic ash continued to provide new evolutionary opportunities. Different types of ash contained different mineral compositions, creating microenvironments with unique chemical signatures. Organisms began to specialize, not just in terms of temperature or pressure tolerance, but in their ability to process specific mineral combinations. Iron-rich ash supported the evolution of organisms with enhanced photosynthetic capabilities. Their cellular machinery, incorporating metal atoms in ways that increased their efficiency at capturing the minimal light available. Sulfur-bearing ash created communities of organisms that could process these compounds into complex organic molecules, essentially performing chemistry that had previously required the high temperatures and pressures of volcanic vents. The most remarkable development was the emergence of organisms that could survive in multiple phases of water simultaneously. These liminal beings existed at the boundary between liquid and solid, able to remain active in water that was partially frozen, extracting nutrients from ice itself, while maintaining metabolic processes that required liquid chemistry. Evolution in this environment proceeded along multiple parallel tracks, creating a diversity of solutions to the problem of existence under extreme conditions. Some organisms chose the path of maximum efficiency, reducing their metabolic processes to the bare minimum required for survival and reproduction. Others chose complexity, developing elaborate cellular machinery that could extract energy from increasingly marginal sources. The timescales involved in these evolutionary processes were vast by any measure except geological time. Mutations that would have provided immediate advantage in the energy-rich surface world required thousands of generations to demonstrate their value in the austere conditions of the deep ocean. Natural selection proceeded with the patience of stone, testing each innovation against the unforgiving constraints of an environment where failure meant extinction and success meant merely the opportunity to face the next challenge. Yet within these constraints, life found ways to flourish that defied every prediction. The organisms that emerged from this evolutionary crucible were streamlined, elegant, efficient, beyond anything that had existed in the chaotic abundance of the surface world. They were life distilled to its essential functions, purified by pressure and scarcity, into forms that wasted nothing and accomplished everything. In the cradle of shadows beneath the ice, evolution had learned to sculpt with darkness itself, creating beings of such austere beauty that they seemed more like mathematical equations than biological organisms. They were the children of impossibility, proof that life could not only adapt to any conditions, but could find in those conditions the inspiration for forms of existence that transcended the limitations of their environment. The whispered awe of their existence echoed through the dark water like a prayer spoken in a language that only molecules could understand. 10 million years passed like a single breath held too long. In the space between one geological epoch and the next, the ice had become something more than frozen water. It had become time itself, stratified, compressed, crystallized into layers that recorded the passage of ages with the precision of a cosmic clock. Each stratum told the story of a different era, the first desperate years when life had struggled against the cold, the long millennia of stasis when nothing changed, the recent centuries when volcanic ash had begun to stir new possibilities in the depths. The continents, those vast rafts of stone that had once defined the surface geography of the planet, were no longer recognizable as separate entities. Under the weight of ice miles thick, they had been pressed down into the Earth's mantle like fingerprints in clay. The very shape of the planet had changed, its surface flattened and smoothed by the patient grinding of glaciers that moved with the slowness of continental drift. Mountain ranges that had taken tens of millions of years to rise had been erased, in a fraction of that time, ground down to their roots by ice that flowed over them like slow-motion water. Valleys had been filled with compressed snow until they became part of the uniform white surface that stretched unbroken from pole to pole. The Earth had achieved a kind of geometric perfection, its surface becoming a nearly perfect sphere that reflected sunlight with mathematical precision. Deep beneath this transformed surface, the hidden ocean had become a repository of memory, in ways that the surface world could no longer claim. In the darkness between ice and stone, organisms carried within their genetic code the accumulated wisdom of millions of years of survival under impossible conditions. They were living libraries, each species a different volume in the encyclopedia of extremity, each individual a sentence in the ongoing story of life's refusal to surrender. But what they remembered, and what they had forgotten, posed questions that echoed through the dark water with philosophical weight. The organisms that now populated the deep ocean were so far removed from their surface ancestors that they might as well have been aliens. They had no memory of sunlight, except as encoded sequences in their DNA that served functions they had never experienced. They had no concept of seasons, of weather, of the vast ecosystems that had once covered the planet's surface. Their universe consisted of pressure and chemistry, heat and cold, the simple binary of existence and extinction. Would anyone remember a world before silence? The question haunted the depths like a molecular ghost, carried in chemical messages that organisms pass between communities without understanding their significance. In the genetic code of every creature that lived in the hidden ocean lay fragments of information that had once described a different kind of existence: instructions for processing sunlight, for responding to atmospheric pressure changes, for reproducing in rhythm with planetary cycles that no longer existed. These genetic fossils were maintained not because they served any current purpose, but because the cost of eliminating them was greater than the cost of preserving them. They existed in the cellular equivalent of archived files, dormant sequences that consumed minimal resources, while preserving information that might, someday, under conditions that could barely be imagined, become relevant again. Evolution had become an exercise in forgetting as much as remembering. Traits that had been essential for surface life, the ability to see visible light, to process atmospheric gases, to respond to temperature variations that occurred on time, scales shorter than geological ages, had been systematically eliminated from most lineages as wasteful luxuries that diverted energy from more essential functions. The organisms that survived were masterpieces of selective memory, retaining only those capabilities that served them in their current environment, while discarding everything else with ruthless efficiency. They had become perfectly adapted to their narrow niche, so specialized that they could not survive anywhere else, even if anywhere else had existed. Yet within this specialization lay a paradox that spoke to the deepest mysteries of life itself. The more perfectly these organisms adapted to their extreme environment, the more they preserved, in encrypted form, the potential to readapt to other conditions. Their very efficiency at surviving in the deep ocean required metabolic flexibility that could, under the right circumstances, be repurposed for entirely different forms of existence. The volcanic activity that had punctuated the long silence was itself becoming part of the planet's new rhythm. Every few thousand years, new cracks would appear in the ice. New sources of heat would emerge from the depths, creating temporary opportunities for evolutionary experimentation. These geological events were the heartbeat of the frozen world, the only measure of time that had meaning in a place where seasons and years had become irrelevant. Some organisms had evolved to specialize in exploiting these rare opportunities, developing the ability to rapidly colonize new thermal environments when they appeared, and to enter dormant states when they disappeared. These pioneers existed in a constant state of readiness, their metabolisms poised to take advantage of changes that might occur once in a million years. The ice itself had become a participant in the evolutionary process. Its weight and pressure created unique chemical conditions that influenced the development of the organisms beneath it. Different regions of the hidden ocean experienced different pressures depending on the thickness of the ice above them, creating a mosaic of microenvironments that supported distinct evolutionary lineages. In some areas, where the ice was thickest and the pressure greatest, organisms had evolved forms of metabolism that required these extreme conditions to function. They had become so dependent on the crushing weight above them that they would die instantly if transported to regions of lower pressure. They were prisoners of their own adaptation, captives of the very conditions that had enabled their survival. In other regions, where cracks in the ice occasionally allowed pressure relief, organisms maintained greater metabolic flexibility. These populations served as genetic reservoirs, preserving within their lineages the capacity for change that more specialized organisms had surrendered in exchange for perfect adaptation to current conditions. The memory of the surface world persisted in ways that transcended biology. Embedded in the deepest layers of ice were air bubbles that had been trapped during the Great Freezing, tiny capsules that preserved samples of the atmosphere as it had existed millions of years ago. These bubbles contained gases that told the story of the planet's transition from warmth to cold, chemical signatures that recorded the exact moment when the greenhouse effect had collapsed and winter had claimed the world. But there was no consciousness in the hidden ocean capable of reading these messages. No intelligence that could interpret the chemical diary written in ice and stone. The memory existed, complete and perfect, but it was memory without a mind to remember. History without a historian to tell the story. Time itself had been transformed by the Ice Age. Without the rhythms of day and night, without seasonal cycles, without the biological processes that had once marked the passage of time on shorter scales, the hidden ocean existed in a state of temporal suspension. Millions of years could pass without any observable change in the conditions that defined existence for its inhabitants. The planet had become its own monument, a crystalline memorial to the complexity it had once harbored. Every layer of ice, every mineral deposit on the seafloor, every genetic sequence in every organism carried information about what had been, but that information existed in a form that could only be decoded by intelligences that did not yet exist. In the cosmic perspective, Earth had become a seed of memory buried in the cold soil of space, waiting for conditions that might allow it to germinate into something new. But seeds can wait for a very long time, and some seeds never sprout at all. Would anyone remember a world before silence? The question echoed through the darkness, unanswered and perhaps unanswerable, a philosophical riddle dissolved in the deep water of a planet that had learned to dream in ice. But in the deepest trenches, where pressure had compressed time itself into crystalline moments, something was stirring that had nothing to do with memory and everything to do with possibility. The volcanic ash continued to fall, and with each grain that settled on the sea floor, the mathematics of survival shifted by infinitesimal degrees. Change was coming, though it would take another million years to arrive. In a universe where patience was measured in geological epochs, a million years was barely the space between one breath and the next. The hidden ocean held its secrets close, but secrets, like seeds, have a way of demanding to be born. Deep in the planet's molten heart, something had been building for 10 million years. The Earth's core had never acknowledged the ice age that gripped its surface. While the world above had learned the language of silence and stillness, the interior continued its ancient nuclear burning, generating heat with the same relentless efficiency it had maintained since the planet's formation. But now, after epochs of accumulation, that heat had reached a critical threshold. The tectonic plates, those vast puzzle pieces of rock that formed the planet's skin, began to shift with increasing urgency. Pressure that had been building for geological ages finally found release points, creating volcanic activity on a scale that dwarfed anything the frozen world had experienced since the ice claimed dominion over the surface. The first eruptions came without warning, piercing through miles of ice like needles of fire thrust upward from the depths of hell. But these were not the small, isolated volcanic events that had occasionally punctured the silence of the deep ocean. These were massive outpourings of molten rock and gas that announced themselves with explosions that could be felt through the planet's entire structure. Carbon dioxide, that precious gas that had been locked away in ice and stone for millions of years, began to flood back into the atmosphere in quantities that had not been seen since the warm ages before the freeze. Each volcanic eruption was a breath of fire exhaled by the planet's interior, a gaseous exhalation that carried with it the chemical ingredients necessary for the greenhouse effect that had once kept the world habitable. The ice began to respond to this assault from below with changes so subtle they were almost imperceptible at first. Temperature increases measured in fractions of degrees created microscopic alterations in the crystalline structure of the frozen surface. Ice that had been solid for millions of years began to show signs of stress, developing hairline fractures that spread slowly through the white expanse, like the first wrinkles on an aging face. Steam rose from the volcanic vents with a violence that seemed almost alive, creating clouds that had not been seen in the Earth's atmosphere for 10 million years. These clouds, laden with water vapor and carbon dioxide, began to trap heat in ways that the thin, cold atmosphere had forgotten how to do. The greenhouse effect, that delicate dance between incoming solar radiation and atmospheric chemistry, slowly began to reassert itself. The sound of the eruptions was the first true noise the planet had produced since the Great Silence began. These were not the subtle chemical whispers that organisms exchanged in the hidden ocean, but explosive roars that shattered the crystalline quiet. with the authority of geological process. The reverberations traveled through the ice and stone, creating harmonics that made the entire planet ring like a vast frozen bell. Where volcanic heat met ice, extraordinary transformations began to occur. The boundary between solid and liquid, between frozen death and flowing possibility, became a zone of constant change. Ice sublimated directly into vapor, without passing through the liquid phase, creating clouds of steam that rose through cracks in the frozen surface, like the breath of a world learning to live again. The chemistry of the emerging atmosphere was unlike anything that had existed before the Ice Age. The volcanic gases contained not just carbon dioxide and water vapor, but complex compounds that had been processed in the high-temperature, high-pressure environment of the planet's interior. These chemicals created new possibilities for atmospheric reactions, new pathways for the absorption and retention of solar heat. Deep beneath the ice, the hidden ocean began to feel the effects of the volcanic awakening. Water temperatures rose by degrees that seemed minuscule, but represented enormous changes in the energy balance of the deep-sea environment. Thermal vents that had been quiet for thousands of years suddenly roared back to life, spewing superheated water and minerals into the darkness with renewed vigor. The organisms that had survived the long winter in the depths sensed these changes with the acute sensitivity that comes from millions of years of adaptation to marginal conditions. Chemical sensors that had evolved to detect the faintest traces of nutrients in barren water now registered unprecedented concentrations of dissolved gases and minerals. Growth rates that had been measured in geological time began to accelerate to merely astronomical time. Some species that had survived by reducing their metabolisms to barely perceptible levels suddenly found themselves with access to energy sources they had not exploited for millions of years. Photosynthetic pathways that had remained dormant in the absolute darkness began to stir as the first traces of light penetrated the thinning ice from above. The planet's albedo, that mathematical relationship between reflected and absorbed light that had locked the world in winter, began to shift for the first time since the Ice Age began. The volcanic ash that settled on the ice surface was dark, absorbing solar radiation instead of reflecting it back into space. Each eruption deposited more heat-absorbing material on the frozen surface, accelerating the warming process in a feedback loop that worked in the opposite direction from the one that had created the Ice Age. The magnetic field of the planet, generated by the circulation of molten metal in the core, began to fluctuate as the increased volcanic activity altered the flow patterns in the Earth's interior. These magnetic variations had no immediate effect on surface conditions, but they served as harbingers of the massive changes that were building in the planet's fundamental systems. Atmospheric pressure, virtually non-existent during the deepest phase of the Ice Age, began to increase as volcanic outgassing added mass to the thin envelope of gas that surrounded the planet. This increased pressure had cascading effects on the physics of ice and water, altering the temperatures at which phase transitions occurred and creating new possibilities for liquid water to exist on the surface. The ice sheets themselves, those miles-thick accumulations of frozen water that had defined the planet's surface for so long, began to show signs of internal movement. Pressure from the volcanic heat below created liquid zones within the solid ice, causing massive structures to shift and flow in ways they had not done for millions of years. Cracks appeared in the ice with increasing frequency, some of them extending for hundreds of miles across the frozen surface. These fractures served as release valves for the pressure building beneath, but they also created pathways for heat and gas to reach the surface more easily. The planet was developing a circulatory system again, a network of channels through which energy could flow between the interior and the exterior. The trembling anticipation that characterized this phase of the planetary awakening was felt not just in the geological processes, but in the very molecules of the atmosphere. Chemical reactions that had been impossible in the cold, thin air of the Ice Age began to occur with increasing frequency as temperature and pressure rose. The planet was remembering, at the molecular level, how to support the complex chemistry of a living world. Earth exhaled, and that exhalation carried with it the promise of transformation. The breath of fire that rose from the volcanic vents was more than just heat and gas. It was the planet's announcement that the age of ice was ending, that the long winter was finally giving way to the possibility of spring. The world was learning to breathe again, and each breath was deeper and warmer than the last. The first sound of rain since memory began fell like a benediction on ice that had forgotten water could move. It started as individual droplets, impossibly precious in their rarity, each one a miracle of physics that required precise combinations of temperature, pressure, and atmospheric chemistry that had not existed for 10 million years. The rain fell on a surface that had no memory of such things, striking ice with tiny percussion notes that rang across the frozen landscape, like the tentative first notes of an orchestra, tuning itself for a symphony that had been postponed for geological ages. But what began as gentle precipitation quickly transformed into something far more dramatic and urgent. The volcanic heat that rose from the planet's interior had created atmospheric conditions of unprecedented instability. Temperature gradients that had remained constant for millions of years were suddenly fluctuating wildly as warm, moist air from the volcanic zones collided with the frigid atmosphere that still dominated most of the planet. The result was weather, actual weather, for the first time since the ice had claimed the world. Storms formed with explosive violence, spinning up from the thermal chaos like tornadoes of liquid and gas. These were not the gentle rain showers that had once nurtured surface life, but torrential deluges that carried within them the accumulated atmospheric tension of an entire ice age suddenly released. The rain fell with the fury of water that had been denied its natural cycle for millions of years, as if the sky were weeping with joy and rage simultaneously. Where the rain struck the ice, it began the work of carving that would reshape the planet's surface. Each droplet was a tiny chisel, its liquid warmth capable of melting microscopic amounts of the frozen surface. But the accumulated effect of billions of droplets falling for days and weeks was profound beyond imagination. Channels began to form in the ice, narrow grooves that guided the flow of meltwater along paths determined by gravity and the subtle irregularities in the frozen surface. These channels deepened with astonishing speed. The meltwater that flowed through them was warmer than the surrounding ice, its movement generating friction that accelerated the melting process. What had begun as hairline scratches in the frozen surface became rivulets, then streams, then torrents that carved canyons through ice that had been solid for longer than mountains typically survive. The sound of flowing water returned to the world like a voice that had been silent so long it had forgotten its own timbre. It began as a whisper, the barely audible trickle of meltwater finding its way through microscopic channels in the ice. But as the channels widened and merged, the whisper became a murmur, then a babble, then a roar that echoed across the frozen landscape with the authority of planetary transformation. Rivers were being born from the tears of melting glaciers, each one carving its own unique path through the ice toward the hidden ocean below. These rivers were unlike any that had existed before the freeze. They flowed through landscapes of pure white, carrying with them the dissolved minerals and gases that had been locked in the ice for millions of years. The water that reached the hidden ocean carried chemical messages from the surface world, molecular news that conditions above were changing in ways that the deep-sea organisms had never experienced. The canyons carved by these torrents revealed the history of the Ice Age in cross-section, exposing layers of frozen water that told the story of different epochs in the planet's long winter. Some layers were clear as glass, formed during periods of gradual freezing when atmospheric conditions had been stable. Others were cloudy with trapped air bubbles, recording moments of sudden temperature change when the atmosphere had been more turbulent. Still, other layers contained volcanic ash, dark streaks that marked the eruptions that had punctuated the silence over the millions of years. These ash layers served as chronological markers, allowing the flowing water to read the ice like a geological book, decoding the compressed history of a world that had lost the ability to record its own story in any other way. The euphoria of flowing water was tempered by a profound sense of loss that seemed to permeate the very molecules of the meltwater. This was rain that fell on a world that had forgotten how to receive it, flow that carved through landscapes that had never been designed for rivers. The ice that melted to feed these torrents had been the accumulated snow of millions of winters, each flake a tiny piece of the planet's history that was now being dissolved and carried away forever. Yet, in that dissolution, lay the promise of renewal. The meltwater that flowed toward the hidden ocean carried with it not just the chemical history of the Ice Age, but the potential for new kinds of chemistry to occur. Dissolved minerals that had been locked away in solid form for millions of years were suddenly available to participate in the complex reactions that could support life. The temperature of the meltwater varied dramatically depending on its source and the path it took to reach the ocean. Water that had been heated by direct contact with volcanic vents could maintain temperatures well above freezing even as it flowed through channels carved in sub-zero ice. This created thermal stratification in the newly formed rivers, with warm water flowing along the bottom while cooler water moved along the surface, creating circulation patterns that mixed dissolved chemicals in novel ways. The sound of these rivers was more than just the physical noise of water in motion. It was the sound of time itself, beginning to flow again, after eons of crystalline suspension. The rhythmic gurgle and splash of moving water marked the return of short-term change to a world that had known only the slow, imperceptible transformations of geological time. Some of the rivers flowed with such violence that they created their own weather systems, throwing up clouds of spray and vapor that interacted with the cold air to create localized snow and rain. These microclimates were the first instances of complex weather patterns since the Ice Age began. Tiny laboratories where the planet experimented with the atmospheric dynamics it had forgotten how to manage. The chemistry of the flowing water was extraordinarily complex, containing dissolved gases from volcanic sources, minerals leached from the ice, and organic compounds that had been preserved in frozen form since before Great Winter. This chemical cocktail created opportunities for reactions that had been impossible during the static conditions of the Ice Age. Where rivers converged and merged, the mixing of different chemical signatures created zones of enhanced reactivity. These confluence points became hotspots of chemical activity, places where the dissolved remnants of the pre-ice world combined with the volcanic products of the awakening planet to create entirely new molecular possibilities. The tears of stone that flowed down these newly carved channels carried with them the grief of a world that had lost its complexity and the joy of a world beginning to remember what it meant to be alive. Each drop contained within it the history of the freeze and the promise of the thaw, the sorrow of extinction, and the hope of renewal. The planet wept, and in its weeping, it began to heal. The first sound of rain since memory began was also the first note of a song that would grow in complexity and beauty as the ice continued to retreat, as the rivers continued to carve, as the world continued its long journey back to the light. Water flowed, and in that flowing, time itself began to move again. Light touched water, and the world remembered color. After 10 million years of white silence, the moment when open ocean met unfiltered sunlight was a revelation so profound it seemed to redefine the very nature of illumination. The hidden sea, that dark realm that had harbored life through the long winter, suddenly found itself exposed to the electromagnetic radiation of the sun for the first time since the ice had sealed it away from the sky. The transformation was not gradual. When the ice finally retreated enough to expose significant areas of liquid water to direct sunlight, the change was swift and dramatic. Photosynthetic organisms that had survived for millions of years on the faintest traces of light, filtering through cracks in the ice, suddenly found themselves immersed in an abundance of energy that bordered on the overwhelming. Cyanobacteria, those ancient architects of Earth's atmosphere who had maintained a tenuous existence in the deep ocean, responded to the return of light with an explosion of activity that painted the newly exposed waters in shades of blue and green that had not been seen since before the freeze. These simple organisms, barely visible as individuals, created vast blooms that stretched across hundreds of square miles of ocean surface, transforming the grey waters into gardens of microscopic life. The photosynthesis that had been dormant or barely functional for so long suddenly roared back to full activity, releasing oxygen into the atmosphere at rates that had not been achieved for millions of years. The very chemistry of the air began to change as these tiny organisms worked their ancient alchemy, converting carbon dioxide and water into organic compounds and releasing molecular oxygen as a waste product that would prove essential for the evolution of more complex life. The light that fell on these blooms was itself different from the light that had illuminated the world before the Ice Age. It had been filtered through an atmosphere that contained new combinations of gases, volcanic compounds that created subtle alterations in the spectrum that reached the surface. This light carried with it energy in wavelengths that the photosynthetic organisms had to learn to process, driving rapid evolutionary adaptations in their light-harvesting machinery. The water itself had been transformed by its long imprisonment beneath the ice. It contained dissolved minerals and chemical compounds that had accumulated over millions of years, creating nutrient concentrations that were unlike anything that had existed in the surface oceans before the freeze. This chemical richness provided the raw materials for explosive biological growth once light became available to power the processes of life. The temperature of the exposed ocean was a complex mosaic of thermal zones created by the interaction of volcanic heat sources, melting ice, and solar warming. Some areas were warmed by underwater thermal vents, creating tropical conditions in a world that was still emerging from an ice age. Other areas remained near freezing, their temperatures held down by the continuing presence of ice sheets and the thermal inertia of water that had been cold for millions of years. This temperature variation created circulation patterns in the ocean that were entirely new, different from anything that had existed before the Ice Age. Cold, dense water from the polar regions mixed with warm, mineral-rich water from volcanic zones, creating currents that transported nutrients and organisms across vast distances. These new circulation patterns served as highways for the dispersal of life, carrying genetic material and chemical resources to regions that had been isolated for millions of years. The diversity of life that emerged in the exposed ocean was remarkable in its speed and complexity. Organisms that had been compressed into a few specialized lineages during the Ice Age suddenly found themselves with access to new energy sources and new environmental niches. Evolutionary experimentation proceeded at a pace that was rapid even by the standards of normal geological time. Some organisms developed new forms of photosynthesis that could take advantage of the altered light spectrum created by the volcanic atmosphere. Others evolved enhanced mechanisms for processing the unusual chemical cocktail that characterized the post-ice ocean. Still others developed new forms of cooperation and symbiosis, creating biological partnerships that could exploit the diverse conditions of the transforming world. The sound of the ocean had returned, along with its visibility. Waves, driven by winds that were themselves a new phenomenon in the post-ice world, created the rhythmic percussion of water against ice and stone that had been absent for millions of years. This sound carried with it chemical messages as dissolved compounds were mixed and aerated by the mechanical action of moving water. Bioluminescence became common in the surface waters, as organisms developed new ways to create and use light in an environment where illumination was no longer a scarce resource. These displays of biological light created patterns of blue and green radiance that danced across the ocean surface, visible evidence of the chemical processes that were transforming the marine environment. The horizon, that line where ocean met sky, became visible for the first time in 10 million years. This simple geometric boundary represented a profound philosophical shift, the return of perspective, of depth, of the three-dimensional thinking that becomes possible when a world has distance and space, rather than the uniform whiteness that had characterized the Ice Age. Weather patterns began to establish themselves over the open ocean with increasing complexity. Evaporation from the sun-warmed surface created clouds that could travel vast distances before releasing their moisture as rain, creating cycles of precipitation that connected distant parts of the planet through the circulation of water vapor. These weather systems were the planet's first attempts to re-establish the global circulation patterns that had once distributed heat and moisture around the world. The chemical signature of the ocean was constantly changing as new sources of dissolved materials became available. Rivers carved through melting ice carried fresh inputs of minerals and organic compounds that had been locked away for millions of years. Volcanic activity contributed new chemical species that had been processed in the high-temperature environment of the planet's interior. The interaction of all these inputs created a dynamic chemical environment that supported rapid evolution and ecological innovation. Marine food webs began to establish themselves with startling speed as organisms that had been limited to simple chemical energy sources suddenly gained access to the abundant energy of photosynthesis. Primary producers like cyanobacteria supported growing populations of organisms that fed on them, which in turn supported predators and decomposers that had been nearly extinct during the Ice Age. The three-dimensional structure of the ocean began to develop as organisms colonized different depth zones according to their light and temperature requirements. Surface waters became dominated by photosynthetic organisms that could take full advantage of solar energy. Deeper waters harbored species that had evolved during the Ice Age to function in darker, colder conditions. The boundary zones between these layers became areas of intense biological activity as species adapted to intermediate conditions. The ocean had returned not as a simple restoration of what had existed before the Ice Age, but as something entirely new, a marine environment that combined the evolutionary innovations developed during the long winter with the energy abundance that came with the return of light. It was an ocean that carried within its waters the memory of both death and survival, the chemical signature of both ending and beginning. Light reclaimed the surface of the world, and in that reclamation, the planet began to remember what it meant to be beautiful. The gentle radiance that painted the waters in blues and greens was more than just electromagnetic radiation. It was the visible manifestation of life's refusal to surrender, the optical proof that even the longest winter could not extinguish the fundamental processes that made existence possible. The sea had returned, bringing with it the promise that complexity could emerge from simplicity, that abundance could follow scarcity, that worlds could learn to live again. In the space between extinction and possibility, life discovered new forms of mathematics. The world that emerged from the ice was not a restoration of what had been, but an exploration of what could be. The organisms that had survived the Great Winter carried within their genetic codes not just the memory of ancient adaptations, but the evolutionary innovations that had been forged in the crucible of impossible conditions. They were the inheritors of both worlds, the abundant past and the austere present, and from this inheritance they began to construct forms of existence that transcended the limitations of either. Oxygen rose in the atmosphere with unprecedented speed, a gaseous revolution that transformed the very chemistry of life on Earth. The cyanobacteria that bloomed in the newly exposed oceans were producing molecular oxygen at rates that had never been achieved in the planet's history, flooding the air with a reactive gas that opened entirely new possibilities for energy metabolism. For organisms that had evolved in the oxygen-free environment of the deep ocean, this atmospheric change represented both opportunity and crisis. Oxygen was toxic to many of the anaerobic metabolisms that had sustained life through the Ice Age, forcing rapid evolutionary adaptations in species that had remained stable for millions of years. Some organisms developed mechanisms to neutralize the harmful effects of oxygen, while others learned to harness its reactive power for more efficient energy production. The rise of aerobic metabolism, the ability to use oxygen to extract energy from organic compounds, represented a quantum leap in the efficiency of biological processes. Organisms that had survived on the marginal energy sources available during the Ice Age suddenly gained access to metabolic pathways that could produce 20 times more energy from the same raw materials. This metabolic revolution provided the energetic foundation for the explosion of complexity that followed. Multicellularity, which had existed in primitive forms during the Ice Age, began to evolve along entirely new trajectories. The increased energy availability that came with aerobic metabolism made it possible to support larger, more complex organisms with specialized cell types that could perform distinct functions. The first true multicellular organisms were microscopic marvels of biological engineering, clusters of cells that had learned to differentiate and cooperate in ways that exceeded the sum of their individual capabilities. These early multicellular pioneers were the ancestors of all complex life that would follow, but they were shaped by the unique conditions of the post-ice world in ways that distinguished them from anything that had existed before the freeze. They had evolved from organisms that had survived under extreme conditions, and they retained metabolic flexibility and stress resistance that gave them remarkable resilience in the face of environmental change. Sexual reproduction, that fundamental innovation that allows organisms to combine genetic material from different individuals, underwent rapid evolution as populations that had been isolated for millions of years suddenly came into contact with each other. The genetic diversity that had been preserved in scattered populations during the Ice Age was suddenly available for recombination, creating hybrid organisms with novel combinations of traits that had never existed together before. The diversification of life forms proceeded along multiple parallel tracks, as different lineages explored different solutions to the challenges and opportunities of the transforming world. Some evolved toward greater size and complexity, developing multicellular organizations that could exploit resources unavailable to single-celled organisms. Others evolved toward greater efficiency and specialization, becoming highly adapted to specific environmental niches. The development of predation and herbivory created the first complex ecological relationships since the Ice Age began. Organisms that had coexisted peacefully in 25-2, the resource-scarce environment of the deep ocean suddenly found themselves in competitive relationships, as some species evolved the ability to feed on others. These predator-prey dynamics drove rapid evolution in both offensive and defensive capabilities, creating an arms race that accelerated the pace of evolutionary change. Symbiosis, which had been essential for survival during the Ice Age, evolved into increasingly sophisticated forms of cooperation. Organisms that had originally entered into temporary partnerships for mutual benefit began to develop permanent associations that blurred the boundaries between species. Some of these symbiotic relationships eventually became so intimate that the partners could no longer survive independently, creating composite organisms that were neither fully individual nor fully collective. The chemical communication systems that had evolved in the darkness of the deep ocean were adapted for use in the light-filled surface waters, creating the first complex information networks since the Ice Age began. Organisms began to coordinate their activities across vast distances, sharing information about resource availability, environmental conditions, and reproductive opportunities through molecular messages that could travel with ocean currents. Photosynthetic organisms began to experiment with new ways of capturing and using light energy, developing more efficient light harvesting complexes and new biochemical pathways for converting solar energy into chemical energy. These innovations increased the primary productivity of marine ecosystems, creating more abundant food sources for the growing diversity of organisms that fed on photosynthetic species. The three-dimensional structure of marine ecosystems became increasingly complex as organisms evolved to exploit different depth zones, temperature ranges, and chemical environments. Vertical migration patterns developed as some species learned to move between different zones to take an advantage of varying conditions throughout their life cycles. The evolution of mineral skeletons and shells began during this period as organisms developed new ways to protect themselves from predation and environmental stress. These biological structures were the first hard parts that many lineages had ever produced, representing a fundamental shift in the relationship between organisms and their physical environment. Cell specialization within multicellular organisms reached new levels of sophistication as different cell types evolved to perform specific functions with increasing efficiency. Digestive cells, reproductive cells, structural cells, and sensory cells began to appear as organisms learned to divide biological labor among specialized components. The emergence of biological rhythms synchronized with planetary cycles marked the return of temporal organization to life processes. Organisms began to develop internal clocks that could track daily and seasonal patterns, allowing them to coordinate their activities with predictable environmental changes for the first time since the Ice Age began. From extinction came possibility, not just the possibility of survival, but the possibility of forms of existence that had never been imagined. The organisms that emerged from the post-ice evolutionary explosion were not simply replacements for what had been lost during the freeze. They were new experiments in the organization of matter and energy, new solutions to the fundamental challenge of creating and maintaining complexity in a universe that tends towards simplicity. The Age of Becoming was characterized not by the restoration of the past, but by the exploration of futures that had been made possible by the unique conditions of the post-ice world. Life had learned new lessons during its long sojourn in the darkness, and those lessons became the foundation for innovations that would shape the subsequent history of biological complexity on Earth. The planet had become a laboratory for the investigation of what life could become, when it was given the opportunity to start over with the wisdom of survival and the energy of abundance. The results of that investigation would echo through geological time, influencing the evolution of every organism that would ever live on Earth. Reverence and rebirth intertwined in the molecular dance of organisms that carried within their cells the memory of death and the promise of resurrection, creating forms of beauty that had never existed in any world before or since. The planet remembers everything. In the crystalline structure of glacial ice, still locked in polar regions, in the chemical composition of deep ocean waters, in the genetic sequences of every organism that survived the Great Winter, the memory of Snowball Earth persists like a whispered secret, passed down through 4 billion years of planetary history. Every breath you take contains molecules of water that once fell as snow in that ancient winter, that were compressed into ice under the weight of geological ages, that eventually melted and evaporated and condensed again in the endless circulation that connects all water on Earth across all time. The oxygen that fills your lungs was exhaled by cyanobacteria that learned to photosynthesize in the dim light that filtered through miles of ice, descendants of organisms that refused to surrender to the darkness. The carbon in your bones was once locked away in frozen oceans, part of the vast reserves of dissolved carbon dioxide that were released when the ice finally melted and the seas returned to the surface. The iron in your blood carries the chemical signature of volcanic processes that helped end the Ice Age, metal atoms that were forged in the planet's interior and brought to the surface by the geological forces that awakened the frozen world. You are made of memories, and those memories include the deepest winter Earth has ever known. The evolutionary legacy of Snowball Earth shapes the fundamental architecture of life on our planet in ways both obvious and subtle. The cellular mechanisms that allow organisms to survive extreme cold, the metabolic pathways that can function in low-oxygen environments, the symbiotic relationships that enable cooperation under stress, all of these innovations trace their origins to the survival strategies developed during the long freeze. Multicellular life itself bears the imprint of the Ice Age in its most basic organizational principles. The cooperation between cells that makes complex organisms possible was refined in the crucible of scarcity, where individual survival required collective action. The genetic codes that govern development and reproduction carry within them the accumulated wisdom of millions of years of survival under impossible conditions. Even the rhythms of your daily existence echo patterns established during the post-ice recovery, the circadian cycles that regulate sleep and waking, the seasonal responses that affect mood and behavior, the deep biological awareness of light and darkness that shapes human psychology. All of these connect you to the moment when Earth emerged from its crystalline sleep and life learned to dance with the sun again. The landscapes you inhabit were carved by the ice and shaped by the melt. Every valley, every plain, every distribution of minerals in the soil carries the geological signature of the Great Freeze. The continents themselves were pressed and molded by the weight of ice sheets, their current configurations influenced by tectonic processes that responded to the massive redistribution of frozen water across the planet's surface. Climate patterns that seem natural and eternal are actually recent innovations, atmospheric circulation systems that developed as the world learned to breathe again after millions of years of thin, cold air. The weather you experience, the seasonal patterns that mark the passage of years, the ocean currents that moderate global temperature, all of these are products of the planetary awakening that followed Snowball Earth. In the fossil record, the discontinuity is clear. Before the ice, simple life. After the ice, the explosion of complexity that would eventually give rise to every form of biological organization we recognize today. The great diversification events that produced the ancestors of plants and animals, fungi and protists, all trace their origins to the evolutionary laboratory created by the post-ice world. But the memory of ice goes deeper than biology and geology. It exists in the fundamental particles that compose matter itself, in the atomic nuclei that were formed in ancient stellar furnaces and have circulated through countless cosmic cycles. The very elements that make up your body were forged in stars that died billions of years ago, scattered through space, gathered into the disk of matter that would become the solar system, and eventually incorporated into the rocky planet that would experience its own cycles of warmth and cold, life and death, ending and beginning. You are stardust that learned to remember, and among the memories encoded in your stellar heritage is the recollection of a world that spent 10 million years learning the mathematics of silence. The philosophical implications of Snowball Earth extend beyond the scientific narrative into questions that touch the deepest mysteries of existence. If life could persist through such extremity, if complexity could emerge from such simplicity, if beauty could be born from such desolation, what does that suggest about the nature of possibility itself? Perhaps the most profound legacy of the Ice Age is the demonstration that endings are not final, that what appears to be death can be transformation, that the universe possesses an inexhaustible capacity for surprise. The frozen world, that seemed to represent the ultimate triumph of entropy over organization, became instead the foundation for new forms of order, more intricate and beautiful than anything that had existed before. In the cosmic perspective, Snowball Earth was a brief episode in the history of a small planet orbiting an ordinary star. But for those who inherited its legacy, for every organism that has ever lived in the post-ice world, for every consciousness that has ever contemplated its own existence, it represents something far more significant. It is proof that life finds a way, that complexity emerges from chaos, that the universe tends not toward emptiness, but toward ever greater forms of meaning and beauty. The wind that moves through the trees outside your window carries molecules that once circulated in the thin atmosphere above a frozen world. The sunlight that warms your face follows the same path through space that it followed when it fell on endless fields of ice, reflected back into the cosmic dark by a planet that had forgotten how to absorb warmth. Every sunset is a reminder that darkness is temporary, that even the longest night eventually gives way to dawn. Every season is an echo of the great thaw, the planetary awakening that proved that winter, no matter how deep or enduring, cannot last forever. The stars that shine in the night sky are the same stars that look down on Snowball Earth, unchanged witnesses to the transformation of a frozen world into a living one. They have watched countless worlds undergo their own cycles of growth and decline, warmth and cold, complexity and simplicity. Some of those worlds never awakened from their winters. Others may still be sleeping, waiting for their own geological alarm clocks to sound. But Earth awakened, and in awakening, it created the conditions that would eventually give rise to minds capable of contemplating their own origins, to consciousness capable of remembering its own history, to intelligence capable of recognizing the miraculous in the mundane. Every breath you take is an echo of that frozen world. Every heartbeat a rhythm learned in the depths of the hidden ocean. Every thought a firing of neurons that carry within their chemistry the accumulated wisdom of survival and transformation. We live because once, long ago, the world learned to wake. The memory of ice flows through your veins, crystallized into the very structure of your being, a reminder that you are part of a story larger than any individual life, longer than any single world, deeper than any ocean, and more enduring than any ice. And in that memory, the planet dreams of all the worlds it has been, and all the worlds it might yet become.